Hey guys, in this video I will be analyzing a malware sample named Keylogger 1 using Process Monitor and FakeNet to support. So Process Monitor will help me analyze the malware interaction with system processes, registry keys, and file systems. And FakeNet is an emulation tool designed for malware analysis. So first of all, let's start FakeNet. So to start FakeNet, you can just go to command prompt, run as administrator, and then essentially copy copy the file path to it. I usually prefer that this way because I get used to using command prompt, which is better, and you can just run it, execute it. Okay, so once our FakeNet is executed, I will be minimizing it and then start with our malware analysis. So let's start with our process monitor. I usually start off like that. As you can see, it's capturing a lot of information at the moment, and then in this case I prefer to pause the capture, clear all the events that have been captured, disable it, and then we wanted to run our malware first, while also capturing it as soon as possible, so that process monitor will capture whatever this KL1, which is the keylogger exe file, trying to execute itself to the system. Okay, let's run this KL1 now. Okay, I'll start my capturing as well. As soon as I run it, I'll let it run for 3 to 4 minutes before I start analyzing. After the malware has been executed after a while, I'll pause the capture now, and then we'll start analyzing it. So with process monitor, the key important function here is the filter. So let's see what our malware trying to do. What we can do is to click on filter, go to process name, because it's KL1, which is the process name, and then we will be searching for KL1. Yep, let's see what it's trying to do. We just add it, apply. This will show narrow down to about 4,500 events regarding KL1. See what it's trying to do. From what I can see here, it was trying to create a lot of DLL files, also getting information from there as well, modifying our registry key, load an image, another image like this one, another image here. Okay, so let's see. First of all, we'll check if it's trying to communicate with other network. So in order to do that, with process monitor, we'll go back to our filter, go to operation, so we can see what sort of thing it's trying to do. To operation, and then contains, and type TCP. So we just add it, and then see if it's trying to have any network communication. From what I see, after this behavior here is a key indicator that the malware primary function is to exfiltrate sensitive information, such as keystroke, to another remote server. Therefore, this one designed to transmit information without the user knowledge. And then we can see that the network communication observed through process monitor confirms that Keylogger 1 here is successfully attempt to contact intended destination for data exfiltration. Although it shows reconnect here, the reason is that for malware analysis, you don't want to have a network connection enabled, which could affect to your local computer if you do not have it proper configured. Since then, I just disable it and then provide an offline analysis. Next, after our network communication, let's see what this malware is trying to do. If we go to our process tree, we can see that it was trying to execute multiple exe files, but this looks a little bit suspicious. Why it's trying to create another Windows error reporting fault.exe file. So this is just typically associated with Windows error reporting. In this case, we can see that the malware is exploiting that exe for malicious purposes, performing DL injection. According to this, if we scroll through it, I have set the filter contains like sysfile64. A bit of context here. Sysfile64 is a critical directory on 64-bit Windows systems, which handles like 32-bit applications. So attackers often target this directory as it provides a way to inject code into the 32-bit processes on 64-bit systems effectively by passing some security measure. This technique, known as DL side loading, as you can see here, a lot of DLs have been loaded. They injected to ensure that the malware achieves persistence, meaning it can reload automatically when the system reboots. Look, so once all the DL has been injected, process create, then it exits all of them. See? Process exit. But the malicious code remained active and undetected in this system. So the exploitation of this window error reporting fault, exe, as part of the infection process, highlight how this keylogger leveraged DL side loading. This method usually trick a legitimate executable into loading a malicious DL, which in turn allow the malware to hijack trusted window processes. By using trusted system processes, the malware can evade traditional security measure. I think it makes it more difficult for antivirus software to detect. More than that, this side-loaded technique helps Keylogger exe achieve persistence, ensure its continuity to run even if the system reboots. After the DL injection, the malware shifts its focus to interacting with the Windows registry, which is often a key component in achieving persistence on a system. Specifically, it performs a rich create key operation on the following path here. So this path indicates that the malware is creating or modifying system policies or restrictions. Therefore, it's followed by reg set info key, where the malware likely modifies key settings to ensure its changes are applied. Then the query section is to confirm the key status, which is success. The creation and modification of these critical registry entries establish the malware foothold in the system. And then finally, the malware execute a close key, indicating the registry modification were successful and complete. In conclusion, the primary objective of this keylogger is to capture a sensitive data, specifically keystrokes, and exfiltrate this information to a remote server. It's achieved by first establishing communication with a command and control server through outbound connection, as we from what we observed. And then the malware then exploit the worfault.exe, which is the Windows error reporting fault .exe file, to perform a DL side loading attack, injecting malicious DL files into system to hijack legitimate process and maintain persistence. From what I can see, the malware is trying to allow itself to survive in a system reboot and continue its data exfiltration activity to be unnoticed or undetected. And also, it manipulates Windows registry keys by modifying a lot of critical keys, which help evade detection and remain functional over extended periods that it requires to. So this analysis shows that the Keylogger 1.exe use a combination of network exfiltration, DLL side loading, and registry modification to operate undetectedly on the system and achieve its core mission of stealing sensitive user data.